CircuitPython squad, it's Prof G. Call Link, Pete, and Julie and add Blinka too because our squad is going to get mod with the Python mod operator. We'll learn neat techniques for creating a circular like pattern using Modulo, and we'll learn about the ternary operator. And even though 3 is a magic number, one line of code will rule them all. Let's learn big. So, students of CircuitPython, in our last lesson we presented a solution to the Fidget Dot challenge. Now there are a lot of ways to solve this, and in this lesson I want to return to that code to show you a couple of new techniques, the modulo operator and the ternary operator. Let's start with mod and see how we can implement a code one-liner to loop around a set of lights. Let's plug in our Circuit Playground boards, launch PyCharm, and make a little awesome. And for those of you who are new to the course, you can check out the playlist to see how we got to this point. And first, a bit of setup. Now, if you look at a Circuit Playground with a USB port pointing toward you, the lights are numbered starting at light 0 in the lower right-hand side, then 1, 2, 3, all the way through 9, which is on the side opposite 0. Now, in our last lesson, we showed the solution to the Fidget Dot challenge, and to remind you, the way the Fidget Dot worked was if you pressed button A, you started moving from light 0 in this position counterclockwise. So if we pressed again, we'd go to 1, 2, 3, and if you continue to press all the way up to 9, then if you press one more, then you restart at 0, and 1, 2, 3. So 9 goes back to 0. Now if we press B, we go in the other direction, down to 2, 1, 0. And if we press B one more, well, we're subtracting, but we can't go to -1, so what we do is we reset to 9, then we go 8. So you get the idea. We're spinning all the way around this circle, either in red in one direction or in blue in the other direction. Now in our lesson solution, we showed how to solve this using techniques that you already know. And we got the spinning to work like this. First, if you press button A, we passed in the direction as 1, and if you pressed button B, we passed in the direction as -1. Now we also passed in position, which was the last light that was on, and one of the first things we did was we turned off the last light that was on by setting pixels position to black. Then we added the direction to the position, either 1 or -1. And we used an if-elif statement to get the light to move from 0 to 9 or from 9 to 0. Now this first part would kick in if we were previously at 9 but we added 1 to it by pressing A. That would turn 9 to 10. Well, 10 is greater than 9, so the position would reset to 0 and we'd be able to continue counterclockwise. And in the opposite direction, the elif clause would kick in if our last position was 0, and then we subtracted 1. That would give us a position of -1, which was less than 0, so we'd set the position to 9, and this worked great. But now I'm going to show you a way that we can get rid of the if-elif statement, all 4 lines, and replace it with just one line of code using what's called the modulo operator. Now that operator just looks like a percentage sign, and it's an arithmetic operator. So in the same way that you have plus, minus, star, or slash for addition, subtraction, multiplication, or division, the percentage sign is the arithmetic operator for modulo. What is modulo? All it does is it returns the remainder, the amount that's left over when you divide one value by the other. Let me show you some examples. 10% 10 is 10 modulo 10, which means 10 goes into 10 one time with 0 left over. That's a remainder 0. So we throw away the one time. We don't care about that, but we return 0. It's evenly divided. What about 21 mod 10? Well, 10 goes into 21 two times with 1 left over. We throw away the 2, we return that remainder of 1, so the answer is just 1. 1257 mod 10 is 7, because 10 goes into 1257 125 times. We don't care about the 125, we care about the remainder, which is 7. 7's left over. Now what if the numerator is less than 10? Well, if we have 0 mod 10, 10 goes into 0 0 times with 0 left over, so that gives us a 0. What about 3 mod 10? 10 goes into 3 0 times, but again, 3 is left over, so we get 3. See how that works? Now this one's a bit trickier. What about -1 mod 10? Well, we get the largest value that's less than or equal to -1 that's also divisible by 10. That's -10. So now to get the remainder, we subtract -10 from -1. -1 minus a -10 equals -1 plus 10. That gives us a 9. That's what we return. Well, now that we know how to do this, look what we can do. We can replace our entire if-elif clause, all 4 lines, with this statement here. Position equals position mod, or percentage sign, 10. If we pass in a value like 3, 3 mod 10, 10 goes into 3 0 times with 3 left over, we're going to light up number 3. But what if we get one of the conditions we need to deal with? If we just added 1 to position 9, well, 10 mod 10 gives us 0, so that's going to light up position 0. Hey, we just moved around in a circle. What if we go in the other direction? If we had 0 when we subtracted 1, we're at -1. Well, -1 mod 10 is going to give us 9, so we're going to go from 0 to 9. That's exactly what we want to do. And what's cool about this technique is it'd work with any number of lights. Say you had a NeoPixel strip with 30 lights in it and you wanted to loop around from 0 to 29 or 29 to 0. Well, instead of saying position mod 10 like we're saying here, you'd say position mod the length of your NeoPixel strip, 30 in that case. And we'll try this out when we work with NeoPixel strips later in the course. But let's try modifying our code to make sure this works. Now I'm assuming you've got your Fidget Dot code up. If not, open it up, copy it, close the tab, and then paste it into code.py. And let's modify our code. I'm going to highlight the 4 lines of the if-elif statement that was in our function. I'm going to command /, that'll put comments in front of it. And then just above the 4 lines I commented out, I'm going to put in position equals position mod, or %, 10. Now save and run. Press A. We start at position 0. Let's press A all the way around. When we get to 9, press 1 more. We get back to 0, so we can add a couple more. Then we can start pressing B to go in the other direction. So here we are at 0 again. Press 1 more time. We loop to 9, and we can head all the way back in the other direction to 0. 1 more, and you're at 9. Perfect, except for one edge case. So if I press reset on my circuit playground, that restarts my program, all of my lights are off, and I press B as my first button. Remember our code, we set our initial position to -1, but if we add -1 to -1, this gives us a -2, and -2 mod 10 is 8, which is a light that's lit up. Oh, not what we want. But we can correct this with an if statement. We could put in the code if position less than 0, then intended position equals 9. And I'll show you quickly if we try this out and we press B as our first button, we're in position 9, working good. Now we are adding some more code in here, but I'll show you how we can add an if statement in a single line using something called the ternary operator. Now the best way to describe the ternary operator is to show you an example. So here's a standard if-else statement. It simply switches a color between red and blue. If the color equals red, set it to blue, else set the color to red. Well, the ternary operator lets us take a 4-line if-else statement, not an elif like we were using, just if-else, and bake it down into 1 line. So here's a comparable statement that does the same thing as this block of code, but in a single line. Color equals blue, if color double equals red, else red. And we can read it like this. Set the color equal to blue if the color is red, else, otherwise, set the color to red. And we can see how these 2 types of statements are related. This part here that I've underlined in blue is the conditional that we check to see if it's true or false. If color double equals red. Now in front of this is what we do if the statement is true, that thing that I'm pointing the green line to. And what's at the end after the else statement is what we do if the statement is false. That's what I'm pointing the red line to. And whatever we get, this one or this one is what we set the color to. Now ternary operators look really efficient if you can boil down 4 lines of if-else code into a single line. Now we just have a 2-line if statement here. We don't have an else clause, but we can still turn this into a 1-liner with a ternary operator because what's implied is if we don't have an else statement is this. Else, if it is not true that position is less than 0, do nothing, which means position equals position. So then we can write the ternary operator like this. Set position to 9 if position is less than 0, otherwise, else, set it to position. You see how these things match up? So let's enter this statement and see how things work. So back in PyCharm, I'm just going to highlight this 2-line if statement and comment it out with command /, that's control / on Windows. And above this block, I'll write our ternary operator position equals 9 if position less than 0, else position. Then I'll save and let's try this out. So we'll press button B first. And that's light 9 looking good. Let's cruise all the way around here. And from 0 to 9, that looks good. And what if we go in the other direction? That looks good. And now just all the way around counterclockwise in red from 9 to 0. Excellent. So now let's change this comment up top to Fidget Dot mod and ternary. And I'll save that to the CircuitPython school folder and then close this extra tab so we're back at code.py. And so we learned how to use the modulo operator and how that can be really useful if we ever need to loop around a series of lights. So we were able to take this if statement, this 4-liner here, and make it only a single statement. Now this did create an issue where we needed to add an if statement before this, but that was our opportunity to learn about the ternary operator, and we boiled that to a single statement. So all in all, we had 4 lines of code that we converted to 2 lines of code. But most important was the big learning. We learned about the modulo operator, the mod operator that returns a remainder, and we learned this can be a very efficient way to create circular patterns with lights. And we also learned about the ternary operator and how we can take 4 lines of if-else code and turn it into a one-liner. But I'll also add one more piece to this big learning. If you're ever faced with a trade-off of less code versus more code that's more readable, it's almost always better to choose readability, even if that means more code. Now ultimately, it's up to you to decide if you think the if statements are easier to understand than mod or ternary operator, but you should definitely know both of those 2 new statements that we learned. You'll regularly see them in standard Python, not just CircuitPython. Now there's some other cool efficient hacks that I'll show you in future lessons, but that's enough for now. Feel free to play around with the concepts that we demonstrated on your own, and until next time when the big learning will continue, keep hacking.